Coming in again with another word problem where we have to figure out the value of some things, and we're going to use we're going to create a system, and the only way I'm going to solve it is using a matrix. Thursday night's date night. Last date night, the theater sold 8,501 tickets, totaled a certain amount of dollars. Matinee admission is $5. Student admission is $6, and regular admission is $8.50. So we have three variables here, and let's create a system here. I'm going to call matinee tickets M. Let's make that a little thicker. Student admission S, and regular R. So what do we know about M, S, and R? We know that we sold a total of 8,501 tickets. So that's our first equation. M plus S plus R should equal 8,501. Okay, M, S, and R aren't the cost of tickets. We already know that. It's the number of tickets. And just remember, the question is going to tell you what your variables represent. How many of each type? So the variable is the number of that type. There's our first equation. Equation number 2. Let's use that 86. Or 80. Wow, 86. 64608 number. What is that? That is using the cost of tickets. We should be able to find that number. So the number of matinee admissions should be multiplied by 5, because that'll give us money made by matinee tickets, plus $6 times the number of students, plus 8.5 times the number of regular admission. And what's that equal to? $64,608.50. We got two equations, but how many do we need? 3. Where's our last equation going to come from? Twice as many student tickets were sold as matinee tickets. Twice as many student tickets were sold as matinee tickets. So the number of student tickets is equal to what? Twice as many as the matinee tickets. 2M. This one's really easy to get mixed up. So what I would look at, I would write an equation and then I would read it again. Twice as many student tickets were sold as matinee tickets. Okay, so if you take the number of matinee tickets and multiply it by 2, you get a bigger number. So should the student number be bigger than the matinee number? Twice as many student tickets, yes. So that's how you can know your equations, right? The reason I wrote it over here is because it's not in the same order as all of these. M column, S column, R column, number. So I need to move this 2M to the other side. Negative 2M plus S equals, what's left on the right side? Nothing. Negative 2M plus S, I'm going to skip a little blank for the R, is equal to 0. So here's our system. We need a matrix to represent our system. Let's use this. So it's going to be a 3 by 4 this time. And we're just going to write all the coefficients. 111, 8501, 5, 6, 8.5, 6, 4, 6, 8.5. And then negative 2, 1, 0, 0. So now I put it in the calculator. I'm only going to do this one way as well. There we go. So second matrix, we're going to go over to math, go up to RREF. If you don't have the 84 plus, or you don't have this capability, so the next step is alpha zoom. If it doesn't take you to this, then go back to the last video and you will see how to do it using your calculator. I got to turn it into a 3 by 4 matrix because I have 3 rows and 4 columns. So there it is. And now you just start entering in all your numbers. Oops, not 5. 8501, 5, 6, 8.5. Big number, 64, 608.5. -2. Whoops. 2, 1. Boom. So there's the number of tickets. We've got 918.58. So this was our output after we did the row reduced echelon form for this. And what does that mean? Well, what was the first column? First column was M. So we have 900 M's. That is 900 matinee. The next column was S. So we have 1,800 students. And then we have 5801 regular. And you can just write your answer like that. You could write it as an ordered triple, but that's the solution.